All right, so today we're going to learn about 11.5 areas of similar polygons. Now recall, if two polygons are similar, then their perimeters are proportional to the scale ratio between them. The area of the two similar polygons have a different relationship. Let's investigate what that will look like. So we're going to use the figure to the right here. The first thing that we're going to do is we're going to find the perimeter of figure A. And then we're going to find the perimeter of figure B. So this is the first figure, that's figure B. And then this is our second figure, which is our figure A. So to find the perimeter of figure A, that's really easy. Well, if we know that this side length here is 9, then this side length must be what? 9. So if this side here is 5, then this side must be what? 5. So I'm going to add up all the sides here. So it's 9 plus 9 plus 5 plus 5. That is going to give you 28. Okay? And then to find the perimeter of figure B, the first thing that we are going to do is label the missing sides, right? So if this side here is 9K, then this side must be 9K. And now if this side here is 5K, then this side must be what? 5K. So 9K plus 9K plus 5K plus 5K. Well, how many Ks are there? 28 Ks. Or we can just say 28K. So what we're going to do is we're going to find the ratio of perimeters. And we're going to go from the first figure to the second figure. So in other words, we're going to go and write our ratio as B to A. Okay, so it's going to be 28K, which is the perimeter of figure B, over the perimeter of figure A, which is 28. Now, 28K over 28, that is what I have now. But remember, we're dealing with a ratio. So with ratios, we must simplify, right? So that 28K over 28, I can simplify by canceling both the 28s out. And that's just going to leave me with K. All right? So the next thing that we're going to do is we're going to figure out the area of figure A. So this is a rectangle. What's the formula for the area of a rectangle? Good. So we're going to write A equals BH. So what's the base? 9. What's the height? 5. So I have 9 times 5, and that is 45. So the area of figure A is 45. 45. And then to find the area of this other rectangle, that's just going to be the same formula. So it's A equals BH. So then what's the base? 9K. 9K. What's the height? 5K. So that's 5K. So what's 9K times 5K? 45K what? Squared, right? So x times x is x squared. 9K times 5K is 45K squared, okay? So then the area of figure B is 45K squared. All right, so we're going to go ahead and find the ratio of areas. Again, we're going to write it from B to A. So B to A. So it's 45K squared over 45. And again, we're dealing with a ratio. Ratios must be what? Simplify. So I can cancel the 45. So I'm left with K squared. Okay? So the ratio of the areas will always be squared compared to the ratio of the perimeters or the scale ratio. Okay? So we've talked about this stuff since the beginning of the school year, right? So what I'm going to do is I'm going to write a little or draw a little chart on my paper. And we're going to list out the one-dimensional objects and the two-dimensional objects that we know and love, right? The first thing before we do that is I want to make sure that since we talked about this already, or just now, we talked about the scale ratio. The scale ratio will always be one-dimensional. So scale ratio will always be one-dimensional, okay? So that's the first thing that I want to make sure I put on paper. Now, again, what I want to do is I want to make sure that we go over this. So give me examples of one-dimensional objects that we've talked about in class. A segment, right? So a segment is a one-dimensional object. A line is a one-dimensional object. Anything else? Give me another example. What about radius? Radius is one-dimensional. Radius is one-dimensional. Someone else give me an example.
Diameter.
Diameter is good. I love that. So diameter is considered one-dimensional. Okay, we can also say diagonals of a rhombus and a kite. We can consider perimeter, right? If I were to add up all the segments together, all the segments are one-dimensional, so in total you're going to get one-dimensional, so perimeter. The perimeter of a circle. What's the perimeter of a circle called? Circumference, right? That's considered one-dimensional, right? So these are good examples of one-dimensional objects. And I'm going to go ahead and just, for safety reasons, I'm going to put etc. because there might be more that we haven't listed yet. But I think this is a good start. All right, so let's go ahead and move on to the right-hand side, 2D, two-dimensional. What objects are considered two-dimensional? Circle. But that all falls under what, right? Shapes, okay. Area, I want to make sure that we write area, right? Because anytime we write our answers, the unit must be what? Squared, right? So we're relating 2D to units being squared, right? So area is going to fall under 2D. We talked about shapes, right? So we said circles, right? So circles is considered, circles are considered two-dimensional. What else? Squares. What else? Rectangles. Rhombi, kites, what else? Anything else? Anything else? Triangles. And then we're going to go ahead and just say etc. because the list could go on, right? So make sure you have this on paper because this is going to help us a lot. Okay? So here we go. Knowing this relationship comes in handy when you don't know all the dimensions of a figure and therefore can't find the area using the area form for that figure. So here we have example number 1. It says that triangle JKL and triangle PQR are similar to each other. The area of triangle JKL, which is the first figure, is 30 inches squared. So I'm going to write A, which is area, equals 30 inches squared. Now, find the area of triangle PQR. This is what we're trying to figure out. We're trying to figure out the area of the second figure, right? And since we're trying to figure out the area of that, that's basically our unknown, okay? So our unknown is going to be x. So the area, for now, for the second figure, is x, okay? So the first thing that I always want to do, the first thing, is to figure out the scale ratio. Okay? So, looking from the first to the second, what do we have here?
12 over 15.
Good, 12 over 15. Okay? But don't forget, we're dealing with ratios. Ratios must be what? Simplified. So, if you want, you can just math enter this. But if I have 12 over 15, what does that simplify to? 4 over 5. So 4 over 5. And I'm going to make a note right here to the side. Always simplify. Always simplify. Okay? So now, look, we have the area ratio. Currently, we have 30 over x. Do we agree? Yes or no? 30 over x? Yes? Okay, so what I'm going to do is I'm going to write 30 over x on the right-hand side of the equal sign. And what I'm going to do is I'm going to compare that to my scale ratio, which is 4 over 5. So, 30 over x equals 4 over 5. Let me ask you something. Are these two ratios proportional to each other? Yes or no? Why do you think yes? Okay. So 4 over 5 and 30 over x, we have these two ratios. Are they proportional to each other? In other words, are they equal to each other? No. Okay? So let me go ahead and tell you, or let me go ahead and ask you this. So this 30 over x, is this ratio one-dimensional or two-dimensional? Two-dimensional, okay? So I'm going to write 2d below the 30 over x, just to remind myself that that is a two-dimensional ratio. That's basically the area ratio between these two figures, right? 30 over x. Now that's 4 over 5. Is this ratio one-dimensional or two-dimensional? One-dimensional, why? Yeah, because look, we have a line segment for this first part and a line segment for this second part, right? Line segments are one-dimensional. So I am writing a ratio between one part to another, right? So this right here, that 4 over 5, is one-dimensional. So the problem here is I cannot solve this problem because these two things are not proportional to each other. So I need to make sure, or I should say that I need to figure out what I can do to make these two things equal. And the best thing here is this. This 4 over 5, which is my main character, yes? Since it's one-dimensional, I actually can square this, square both the 4 and the 5 to make it two-dimensional. Okay? So that 4 squared is now going to become 16, and that 5 squared is going to become what? 25 equals 30 over x, right? So the 16 over 25 is 2d, and the 30 over x is also 2d, in terms of ratios, by the way. So now I have 16 over 25 equals 30 over x. What do you think I'm going to do when I have these two ratios equal to each other now? Cross multiply, butterfly method. So I have what? 16 times x, which is 16x, yes. And then 30 times 25, 750, okay. All I'm going to do right now is I'm going to divide both sides by 16. So 30 times 25, assuming that what you said is correct, divided by 16, that is going to leave me with x equals 46.875. So the area of triangle PQR, that second triangle that we're trying to figure out this whole time, is 46.875 what? Square inches, okay? Y'all, any questions about example number 1? Question? Okay, well, good. All right, we're going to do the thing that we did last class where 1, so you're going to show me with your fingers, right? 1, very bad, 5, very good. Tell me your level of understanding. Go. All right. Good, we have like some 3s and 4s, maybe some 5s, right? Okay. Y'all, any questions about this portion of the notes? Question? Any questions? Okay, so we're going to go ahead and move on. We have example number 2. It says find the area of the second figure, okay? So here's my first figure, here's my second figure. So the area of the first figure is 32 centimeters squared, and we're trying to figure out the area of the second figure, so we're going to call that second figure A equals X, right? Area is equal to X. That's our unknown. All right, so the first thing that we need to do is what? What do we have to figure out? The scale ratio. So I'm going to write scale ratio, and we're going to go from the first figure to the second figure, okay? So what's my scale ratio? 8 over 5. So 8 to 5. Now ask yourselves this. 8 over 5. Can I simplify this? Yes or no? Okay, so I'm just going to make a quick note. Even though you can't simplify this, don't forget to simplify. Don't forget to simplify. All right, that's a general note. It's not for this problem. I'm just saying in general, make sure that you always simplify your scale ratio. All right, so then I'm going to write 8 to 5 equals what to what right now?
32 to X.
What's that?
32 to X.
32 to x, okay? So, 8 over 5. Yes? This ratio, is it one-dimensional or two-dimensional? One-dimensional. So I'm going to make a note. That's one-dimensional. And then the 32 over x, is that one-dimensional or two-dimensional? Two-dimensional. So this 8 over 5, I should do what? Square it. So I'm going to square this. So 8 squared, what's 8 squared? 64. 5 squared? 25. Equals 32 over x. All right. So then 64 over 25 is equal to 32 over x. What should I do here? Cross multiply. So I have, let's see, what do I have here? I have 64x equals 25 times 32. What should I do on both sides? Divided by 64. And then x is, I'm going to give it to you, it's going to be 12.5, right? So the area is 12.5 what? Square centimeters, all right? Any questions about this one? Questions about this one? All right. So we're going to look at the second example here. We have the first figure and the second figure. All right. So the first thing that we have to do is what?
Find the scale ratio.
So the first thing that we're going to do what? Find the scale ratio. So we're going to find the scale ratio. What's the scale ratio between, what's the scale ratio from the first figure to the second figure? 6 to 8. So 6 to 8. All right, is this okay? You have to simplify, all right? You can math enter, or if you simplify this, you get what? 3 over 4. So I'm going to make a note. Simplify. Simplify. All right, so now I have 3 over 4 equals
13.5 over X.
13.5, and this is the figure where I'm trying to figure out the area of. So A is going to be X for that one. So 13.5 over X. This 3 over 4, is this ratio one-dimensional or two-dimensional? One-dimensional. 13.5 over X, is this ratio one-dimensional or two-dimensional? Two-dimensional. What's the problem? You have to square the scale ratio so that they are proportional to each other, right? So I'm going to do that. I'm going to square. So I have 3 squared. What's that? 4 squared. So 9 over 16 equals 13.5 over x. Is that correct? Okay, great. So we have 2D equals 2D. So this ratio is two-dimensional. This ratio is two-dimensional. I can go ahead and cross multiply. So I have what? 9x equals what? 216. Okay. And I'm going to do
Divide by 9 by 9.
that. I'm going to divide both sides by 9. So x is equal to
24.
24 what?
Feet squared.
Feet squared. All right. Questions about this one? Any questions? Okay. All right. So now what we're going to do is we're going to look at example 3. It says use the areas of similar figures to find the missing dimensions. All right. So the area of parallelogram ABCD, which is this figure right here, is 150 meters square. So I'm going to make a note. The area is equal to 150 square meters. And the area of parallelogram FGHJ, which is this figure over here, is 54 square meters. So A equals 54 square meters. Now, if these two parallelograms are similar, Find the scale ratio of parallelogram FGHJ to parallelogram ABCD and the value of x. Okay? So here's the thing. Let me ask you. Right off the bat, can I figure out the scale ratio between these two figures? Yes or no? No. Right? What do I currently have? X and 10. But remember, with scale ratios, it's always a number over a number. Right now, what do we have?
The area.
Yeah, the ratio of areas. Right? That is going to be what? 54 over 150. So 54 to 150. All right, we're still dealing with ratios, right? We're still dealing with ratios. So I should do what with this ratio here? Simplify. So if I math enter this, what do you get? 9 over 25. So I'm going to make a note. So I'm going to make a note. Simplify. That is going to be 9 over 25. This 54 over 150, yes?
Yeah.
That is
The ratio of areas.
ratio of areas, yes. But this is a what type of ratio?
Scale ratio.
No. Two-dimensional ratio. Even if I simplify this, right, that 9 over 25, is this ratio one-dimensional or two-dimensional? Two-dimensional still, right? And what did I say about scale ratios? They must be what?
One-dimensional.
One-dimensional. So what I'm going to do... Okay, I got you. That 9 over 25, right, is currently two-dimensional. Charlie, what am I supposed to do? Square root it, right? So in order for you to find the scale ratio given the ratio of areas, first of all, you need to make sure that you simplify, okay? So that's 9 over 25. Now, I can convert this two-dimensional ratio into a one-dimensional ratio by taking the square root of the top and bottom part of this fraction, okay? So that is going to become, what's the square root of 9? 3. What's the square root of 25? 5. So that is our scale ratio, okay? So I can write 3 over 5 equals what over what?
6 over 10.
Not 6. There's no 6. I don't see a 6. X. X over 10. Then what? What do I do? Cross multiple. But first of all, 3 over 5. One more time. Is this a one-dimensional or two-dimensional ratio? One-dimensional. What about x over 10? One-dimensional. So is it safe for me to cross multiply? Yes. All right. So I'm going to cross multiply. 5 times x, that's 5x. And then 3 times 10, that's 30. So x is equal to? 6. So 6 what? 6
meters squared, not squared.
just meters.
Wait, why are they not squared?
Because it's just a segment, right? Does that make sense? All right. Okay, any questions about this one? All right, cool. Let's take a look at B here. Do I have my scale ratio, yes or no? No, what do I have? The area of ratios, which is 50 over 72. All right, so this is a ratio. I should do what? What is that going to simplify to? 25 over 36, okay? And then this 25 over 36, what type, is this one-dimensional or is this two-dimensional? This ratio is two-dimensional, so I should do what to figure out my scale ratio? Take the square root of 25. 5 over 6. 5 over 6, that is, what type of ratio is this? One-dimensional. 5 over 6 is equal to?
X over 6.
X over 6. All right, x over 6, what type of ratio is that? One-dimensional. Is it safe for me to cross multiply? Yeah, so here we go. So 6 times x is 6x. And then 5 times 6 is 5 times 6. And if I divide both sides by 6, right, I have x on the left-hand side, and then I can cancel the 6's on the right-hand side, so that x is equal to 5. So x is equal to 5 what? Inches. Perfect. Okay? Any questions about that one? All right. let's go ahead and figure out the scale ratio for C. But do we have a scale ratio for C?
No.
No. What do we currently have?
Ratio of areas.
So that is
64, 400 over 64.
400 over 64. What does that simplify to?
25 over 4.
You got 25 over 4? Okay, sounds good. 25 over 4. All right. 25 over 4. Yes?
Yes.
Okay. Is this ratio one-dimensional or two-dimensional?
Two-dimensional.
Two-dimensional. All right, and I should do what to figure out my scale ratio? Take the square root. Square root of 25.
5.
Square root of 4.
2.
So 5 to 2 equals what over what? 40 over x. Are these two ratios, or I should say, are these, yeah, both of these ratios, are they two-dimensional? Yes or no? Good. They're both one-dimensional. So this is 1D, that's 1D. So now I should do what? Cross multiply. So I have 5x equals 40 times 2. All right, so I'm going to divide both sides by 5. I can cancel the 5s on the left-hand side, so x is equal to? Well, look, so I have 40 over 5. 40 over 5, that is 8, right? So now I can cancel these two things. It's 8 times 2, which is 16. So x is equal to 16 what? Millimeters, just millimeters, all right? Great. Any questions about this one?
No, sir.